Hello student, today we will going to discuss how to find packing fraction of hexagonal closed packing in three-dimensional space. As you know that the formula of packing fraction is a space covered by atoms upon total space. Hence, in the case of hexagonal closed packing, first of all, my first case is how to find the total space, that is total volume of hexagon. Clear? And then second topic is what space which covered by the atoms. Clear? So first topic is how to find the total space, that is volume of hexagon. Volume of hexagon is equal to area of hexagon into height. Clear? Here we are going to draw the structure of hexagon. In three-dimensional arrangement of hexagonal closed packing, first layer is hexagon, second layer is triangle, third layer is again hexagon. This type of arrangement is known as AB type arrangement. Clear? So, this is the total volume of hexagon, which may calculate by the area of hexagon into this height. This is the height, and area of hexagon is this. Area of hexagon may be calculated by this concept. One hexagon have 6 triangles. So if we are capable to find the area of one triangle and multiply by 6, then automatically total area of hexagon will be calculated. Area of one triangle, then area of triangle is equal to half into base into height. That is total base 2r. Total base is 2r. Total base is 2r. Total base is 2r. One atom present here, one atom present here, and one atom present at the center. So this and this and this length is 2r. 2r. Clear? Here 2r. So base is 2r. Now how can calculate the value of h? So h sine 60 degree is equal to h upon 2r. This length 2r. So h is equal to 2r sine 60 degree. 2r into root 3 by 2. So to cancel r root 3. This is the height. Clear? Now is equal to 1 by 2 into base. Base is 2r into height r root 3. So you can calculate area of one triangle is equal to root 3 r square. Have any problem? Clear? So total area is equal to 6 into root 3r square. Clear? So 6 root 3 r square. This is the total area of hexagon. Now how can calculate the height? This is the total height, that is this is the half of height. So first of all you calculate this height and multiply by 2, then automatically total height will be considered. Then This is the equilateral triangle. And this height, I want to find this height h by 2. This height is h by 2. This height is h by 2. Triangle A, B, C. First of all, we want to find length AB. Length AB. AB is equal to length AB. AB is equal to cos 30 degree. Why consider 30 degree? Because total height is 60 degree. So half of this total angle is 60 degree. So half of this angle is 30 degree. And this length is R. This length is R. By this length is, may consider x. Then x is equal to R by cos 30 degree. What is the value of cos 30 degree? Root 3 by 2. So R by root 3 by 2. 2R by root 3 is the x. This is the x. That is AB is equal to 2R by root 3. Clear? AB is equal to 2R by root 3. Now the length BC is equal to under root ACA square minus AC square minus ABA square. Clear? So AC square is 4R square, because AC is equal to 2R. Again, AC is equal to 2R. 4R is then 4R square minus ABA square. AB square, and AB is equal to 2R by root 3. 2R by root 3 का whole square. Clear? So BC is equal to under root 3, 4, 12 R square minus 4R square by then to root 8 R square by root 3. Clear? Hence total height h is equal to 2BC is equal to 2 into 2 root 2 into R by root 3. 4 root 2 R by root 3. This is the total height, and this is the total height, and total area is 6 root 3 R square. Hence volume is equal to volume is equal to 4 root 2 R by root 3 into 6 root 3 R square. Root 3 cancel out, and 6 for 24 root 2 R cube is the volume of hexagon. This is the volume of hexagon. Clear? Now I want to calculate the total number of atoms which present in the hexagon closed packing. Clear? total number of atoms. The atoms which present at the corner participate 1 by 6. Total number of atom is 1 by 6 into 12 plus the atom which present at the center participate in 1 by 2, that is 1 by 2 into 2 and 3 atom which participate 100% in this hexagon, because this behave like sandwich between two hexagon, so total participate is 3. Then 2, 1, 3 and 3, 6. Total number of atom is 6. Hence, packing fraction is equal to volume covered by one atom is 4 by 3 pi r cube into total number of atom which is 6 by total volume of the hexagon 24 root 2 24 root 2 24 root 2 r cube. Clear? Which may calculate clear? Now pi 4, then pi by root 2 into 3. By calculation we can find out 0.74, that is 74%. This is the packing fraction of hexagonal closed packing in 3-dimensional. The most important topic, and you can see the any book, the not correct process by which we can find the packing fraction of hexagonal closed packing. Thank you.